It's in the numerator, slide it down. It becomes positive. It's in the denominator, slide it up. It becomes positive. Now, you're going to start writing on that paper I just gave you. You don't need your notebook. All you need is the paper I just passed out to you. Okay, so you're writing on the paper I just passed out to you. So what's this? Again, a lot of this is going to go pretty quick here. What's this right here? Give me the answer, Howard.
1 over x squared.
Okay, now listen. All the rest of this week, you're going to be doing tons of problems with exponents. When you write the final answer, you are not allowed to have any negative exponents in the final answer. All those rules I gave you yesterday, they work for negative exponents. But when you get to the end of the problem, if you have negative exponents, you move them. Be careful. What would be the answer to number 2 up here? It's on your paper. You follow along with me on the handout, because this is how the homework's going to be. Now look, the negative exponent's on the bottom to start. Now, what did I just get that saying you do? Robbie?
X squared.
You slide it up. This goes up to the top and becomes positive. Now that would be over 1, but you don't have to write over 1. What's this? Come on, some of these are going to go really quick. What's this? Max?
1/25.
Okay, it's 1 over 5 to the positive second, but you would not leave that like that. When it's a number, you figure it out. That'd be 1/25. Okay, now, be careful here. What's this equal? These are really fast, what I'm doing here so far. What would this equal? Be careful. There's a common mistake people make. Brandon?
8 over x to the 5th.
Yeah, the negative power is not on the 8. It's only on the x. So this would be 8 over x to the 5th. All right, now you can see how a lot of these are pretty quick. All right, look at number 5 in your paper. You're multiplying 3 things that have the same base. What do you do to the exponents? Gave you the rules yesterday. What do you do when you multiply and the bases are the same? What do you do to the powers? Alex? You add them. So what would that be? X to the atom. Rob?
-5th.
X to the -5th, but can't leave that like that. No negative powers in the final answer. So that would simply equal, Quinn,
1 over x to the 5th.
1 over x to the 5th. All right, now I got to come over here. Now, look, pay attention to this. Somewhere on that paper, you know what? Here, look up here. See down here? See where I have the homework? Off to the right, there's a blank space there. That's where you want to put this. What if you have a quantity? Now you want to get this down, because tomorrow this is going to be even more important. What if you have a quantity to a negative power? Now, you're sitting there probably wondering, well, what's in the quantity? I don't care what's in the quantity. If you have some quantity of whatever with a negative power attached to it, how do you think I want you to write that? You want to do this right away. Now, do exactly what I did here, but it's a quantity. What do you think? Chris?
1 over the quantity to n power of n.
Now, listen, this is going to come up today and really come up tomorrow. You see these quantities here? I didn't put anything in there. When you bring this quantity down here, do you think you're going to change what's in the quantity? No. Whatever's in here is going to be here. The only thing that changes is this will become a positive power. What if you had this? Watch this. What do you think that would equal? Just do the same thing as I was doing over there, except you have a quantity. 1 over some quantity to the negative n. David?
Quantity to the n.
Quantity to the n over 1. Let me come back over here to your worksheet now. Okay, see this number 6? Now, you're listening to what I just said over there? What's the first thing you would do with number 6? See the quantity to a negative power? Now just do what I was just saying to you over there. Give me your first line of work for that. See, what's the matter? Now I got something in the quantity. I told you, I don't care what's in the quantity. There's some quantity to a negative power. Just do that and tell me what to write down. How?
1 over the quantity of 3x cubed.
1 over the quantity of 3x to the positive third. But that's not done. What's the final answer to number 6? Now go ahead and cube everything on the bottom. What's the answer to that? Just cube everything on the bottom. 1 over what? Jack?
27x cubed.
1 over 27x cubed. Okay, now, be careful here. Look at number 7. Somebody? Be careful. A lot of negatives up there. Look. Tell me what to write down first. Rob.
1 over the quantity of negative x.
To the positive bit. See what I did? When you move a quantity with a negative power, do not touch what's in the parentheses. Leave it the same. Okay, now that's not done. What is negative x raised to the 5th power? Watch your signs. If you multiply negative x 5 times, what are you going to get? What's negative x raised to the 5th? Ethan. Negative x to the 5th. All right, take a look at number 8. What do you think you're going to do with the 3 to the negative third? Boys, just keep applying the property. Isn't the 3 to the negative third going to go down in the bottom and become 3 to the third? Watch this. Watch this. Now you see that 3 squared? That's still there. 3 to the negative third comes down to become 3 to the positive third. Do you see this? Now make sure you're marking this on that paper. What's 3 to the second times 3 to the third? Bases are the same. Let's use the rules from yesterday. What's 3 to the second times 3 to the third? Andrew.
1 over 3 to the 5th.
3 to the 5th, right? Add the exponents. Now, when you have numbers like that, don't leave it like that. Well, I need someone to figure out what that is. 3 times 3 times 3 times 3 times 3. Joe.
243.
3 cubes, 27, times 3 is 81. Take 81 times 3 a 5th time, that's 243. So when you have a number to a power, go ahead and do it to the number. All right, look at number 9, moving right along. Look at number 9. What are you going to do? What do you do when you have a power to a power? Same rules as yesterday, they still apply. When you have a power raised to a power, what do you do to the exponents? Same as yesterday. Don't worry that one of them's negative, that doesn't matter. The rules still work. Oh man, come on, it's an easy problem. What do you do when you have a power raised to a power? We just did a bunch of them in class yesterday, turned the paper in. It doesn't matter if you have negatives, they still work. Multiply the exponents. And what's that equal? X to the negative 24th, which equals right here.
1 over x to the
1 over x to the positive 24th. Done. Come over here. Number 10. Tell me what to do in number 10. Now number 10 is going to be a 2-step problem. What's the first thing you got to do in number 10? Guys, I told you this is going to go fast. These are still basic problems dealing with exponents. Alex.
We're going to multiply the exponents.
You're going to do that. What's that equal?
M equals negative 6.
M to the negative 6. Bring down the m to the 7th. What's the final answer? You're multiplying two things with the same base. Use the rules from yesterday. The rules ain't never going to change. Chris? M to the 1st, right? Add the exponents. Done. Look at all the answers. There's no negative exponents in the final answer. Now, come on. Let's See how smart you are here. What do you think you're gonna do in number 11? What do you think you're gonna do first? Mike,
Just flip them.
move them. Look, x to the minus second's gonna come down there. X to the minus fifth is gonna go up there. And now, you did this yesterday, didn't you? What do you do when you divide two things that have the same base? You already did this. We did this yesterday. What's the answer? What's x to the fifth over x squared? You did all this in class yesterday for me. Got them all done in class. You're going to do the same thing today here in about 5 more minutes. Howard?
X to the third.
Bigger power, subtract the smaller power, and the answer goes where the bigger one is. Right? Subtract x cubed. 12. What are you going to do first? Moving right along. This is going pretty good here. Come on, what's the first step? What's the top equal? Just use your rules. Use the rules from yesterday, you can't go wrong. Just follow the rules. Quinn?
X to the 6,
No.
or 9.
No. Power to a power. What do you do the exponents?
Oh, you have them?
No. Power raised to a power. You multiply exponents. So that would be x to the...
6.
No. Multiply the exponents. Negative 3 times 2.
Oh, negative 6.
Okay. X to the negative 6 over 4x to the 4th. Boys, pay attention here. Watch this. Tell me what I'm going to do here to finish it. Watch this. You don't want to screw up something like this. What's your next step going to be? You can't leave that like that. You can't have no negative powers in the final answer. What's the matter? These are not that hard. What are you going to do to that? Come on, what are you going to do to that right there? Nate?
Bring the x to the negative 6 down.
So it's going to become x to the 6, right? So what's going to be on the top? A 1, right? That 4 ain't going anywhere. Now look. X to the minus 6 comes down and becomes x to the 6th. There's already an x to the 4th next to it. So what do I have altogether for the x's? Let's use your rules. X to the minus 6 comes down. So what's x to the 6 times x to the 4th? What are you going to have altogether for the x's? Joe? X to the 10. Who has a question? I mean, these are not long problems. Tomorrow, you're going to see in your book, these problems are going to get a little bit more involved. Yep.
I actually had a question about on like number 10.
Yep.
On the second line where it's m negative 6 and then m to the 7, or m to the negative 6 and m to the 7. If you were to drop the 6 under, would that always work too? Because I accidentally did
Yes.
that. And
Here's what he's asking me. M to the 7th, if he took that and brought it down here. That ain't wrong, right? What's m to the 7th over m to the 6th? Still the same answer. You know why I didn't do that? Because these were the same base, so I just added them right away. But what you said is correct. You'd get the same answer. 13, what are you going to do? What's the first thing you're going to do in 13? Come on, look what's there. What are you going to do? Rob,
Flip the x and y.
you're going to move the negative ones. So look. X to the negative 4th is going to come down and become x to the 4th. There's already an x squared down there. What do I got for the x's? Somebody? What do I got for the x's? Andrew?
X to the 6.
X to the 6th. Y to the negative 5th is going to go up and become y to the 5th. There's already a y squared up there. What do you got for the y's? Somebody? Rob? Done? Look at all the answers. There's no negative exponents in them. Now, look at number 14 there. Look. That's this, everyone. That's why I told you that about the quantities. What's the first thing you would do in number 14? Be careful here. Look, you got this big quantity with a negative power on it. What are you going to do? Just boxed it in over there. What are you going to do? Andrew?
Put it under 1.
Put it under 1. Now look. it's gonna be to the positive second. Well, here's where people screw up. What are you gonna do to what's in there? Nothing. You understand? Nothing. The quantity just goes down, and then it'll be to the positive second. So there's your first step. Now, go ahead and use your rules. I showed you this yesterday. Square everything that's in there, and somebody tell me what that is. Just square it, look, you're distributing the exponent now. You're gonna square all that. Rob?
4x to the 4th minus
Whoa, 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 whoa. 4x to the what?
negative 4th,
Negative 4th. Y to the
6.
6th. And finally, you can't leave it like that.
4, or 1, you move the x to the 4th to the top.
Just the one with the negative. That's gonna go up here, and everything else stays where it's at. That went pretty quickly. All I did was show you how to do problems with exponents that have a lot of negative exponents. All right, now, take your iPad out.